Hi everyone, welcome back to my channel Sci Academy. Today we are diving into essential statistic concepts, Pearson's correlation coefficient. If you have ever wondered how to measure the relationship between two variables, this video is for you. So let's get started by defining the Pearson correlation coefficient. Pearson's correlation coefficient denotes as R measures the strength and the direction of linear relationship between two quantitative variables, and the formula of this correlation coefficient is as follows. So R is the covariance between two variables x and y divided by the standard deviation of x times standard deviation of y. So here R is known as the sample correlation coefficient. Some of the properties of R are as follows. The first property is it can be positive or negative. The second one, R lies between two limits, -1 and +1. It is symmetrical in nature. That means the coefficient of correlation between x and y is the same as the between y and x. When we say here R is the covariance of x, y divided by the standard deviation of x times standard deviation of y is the same when we say is covariance between y and x divided by the standard deviation of y times the standard deviation of x. So here r xy is the same as r y x. The fourth property here, that r is a measure of linear association or linear dependence only. It has no meaning for describing nonlinear relations. The fifth and the last property here, although R is a measure of linear association between two variables, it does not necessarily imply any cause and effect relationship. So we illustrate Pearson's correlation coefficient developed so far by considering the data given in the following table. Here we have X, which represents how many hours the students study, and Y represents their exam scores. So if we plot these points on the scatter plot like this, so here Xi and Yi, we find that there is an upward slope, so there is a positive relationship between x and y. But the question here is, how strong is this relationship? As we have already mentioned, we have R is the covariance of two variables x and y divided by the standard deviation of the first variable times the standard deviation of the second variable. If we want to calculate the covariance of x and y, we can say that the covariance of the two variables x and y represents the sum of the products of the differences between x values and the mean of x and y values and the mean of y divided by n minus 1. Here we have divided by n minus 1 because we are talking about the sample which contains 6 students, and we are not talking about the population. So here it is worth to mention these points. If we want to calculate the standard deviation of x, we can say the standard deviation of x equals the sum of x values minus the mean of x all squared divided by n minus 1, all these under the square root. So here the standard deviation of x is the square root of the sum x minus 1, x minus the mean of x all squared divided by the square root of n minus 1. So the same thing for the standard deviation of y. So here is the sum, the square root of sum y values minus the mean of y squared divided by n minus 1. So here R is equal to covariance x and y divided by square root of x, the standard deviation of x times the standard deviation of y, and is equal to the sum of the products x values minus the mean of x and y values minus the mean of y, all these divided by n minus 1, all these divided by square root of the sum x minus the mean of x times the square root of the sum y minus the mean of y, all this divided by the square root of n minus 1 times the square root of n minus 1. So we can read off this, and finally we can get the final formula of the correlation coefficient of Pearson, which is as follows. This is the final formula of the correlation coefficient of R. In order to calculate the correlation coefficient formula, we're gonna need to calculate first x bar and y bar. So x bar is the sum of x values divided by n. So here the x values 2 plus 4 plus 5 plus 8 plus 10 plus 30, we're gonna find here the sum is 42. So 42 divided by 6 equals 7. So the mean of x is 7. So here the mean is 7. The mean of y is the sum of y values divided by n. So here 40 plus 50 plus 60 plus 70 plus 80 plus 90, we're gonna find here 990. So here 390 divided by 6, we find here 65. So here the mean of y is 65. To complete the correlation coefficient, we're gonna need a couple of pieces of the data. The first piece of the data we're gonna need is y values minus x values minus x bar. And so we're gonna ahead and label this table chart, and the next chart value of the column is gonna be y minus the mean of y. The next column is gonna be the products of x values minus the mean of x and y values minus the mean of y. The next column is gonna be x minus x bar squared, and the final and the last and final columns here is gonna be the y minus y bar squared. Now what we want to do is we want to perform the operations that the columns header has, and we're gonna take the sum of every column. So let's begin there. Here we have x minus the mean of x, so we have 2 minus 7 is minus 5. We have 4 minus 7 is minus 3. 5 minus 7 is minus 2. 8 minus 7 is plus 1. 10 minus 7 is plus 3. 13 minus 7 is plus 6. The same process here we redo with y values. So here 40 minus 65, we have minus 25. 50 minus 65 minus 15. 60 minus 65 minus 5, 70 minus 65 is plus 5, 80 minus 65 is plus 15, and finally 90 plus 65 is plus 25. So in order to get the products of x minus x bar and y minus y bar, so here we find minus 5 times minus 25, so here 125, minus 3 times minus 15 is 45, minus 2 times minus 5 is 10, 1 times 5 is 5, 3 times 15 is 45, and finally 6 times 25 is 150. So the sum of these products is 380. Let's square the sums of these columns. So minus 5 squared is 25, minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, 9, and 36. 25 plus 20 plus 9 plus 4 plus 1 plus 9 plus 36, we gonna find here 84. Finally, let's square these columns. So 25 squared is 625, 15 squared is 225, 5 squared is 25, 5 squared 25, so 15 squared is 225, and finally 25 squared is 625. To sum up these values of the columns, we are gonna find here 1750. So now we can easily calculate the R value. So here the R is equal to the sum of this is 380 divided by square root of 84 times 1715. So here we get R is equal to 0.991. So we can say here that there is a strong positive correlation between the two variables x and y, between the hours studied by the students and the exam scores. This is how we calculate R. So let's now testing the significance of correlation coefficient. There is one more thing to consider here. The correlation coefficient is usually calculated with data taken from a sample. In our case, the sample is 6, so n equals 6, so there is just 6 students. However, we often want to test hypotheses about the population. In the case of correlation analysis, we then want to know if there is correlation in the population. For this, we check whether the correlation coefficient is in the sample is statistically significantly different from 0. To test the hypothesis of Pearson's correlation coefficient R, you typically follow these steps. First, the first step here is define the hypothesis. So we have two hypotheses. We have H0, the null hypothesis, R is equal to 0. So the correlation coefficient does not differ significantly from 0. So in other words, there is no linear relationship between the two variables. And we have the alternative hypothesis here. The coefficient, so the alternative hypothesis denotes that R differs significantly from 0. So this is our hypothesis. Thus, there is a significant linear relationship between the two variables. The significance and testing hypothesis can be checked using a t-test. So here we can check this significance by using the t-test. The second step is compute the test statistic t. The test statistic t calculated using the formula. So here the calculated t using the formula, the absolute value of r divided by the square root of 1 minus r squared divided by n minus 2, and n minus 2 here is the degree of freedom. So we find finally the calculated t is as follows here. So this is the calculated t. T is the absolute value times the square root of n minus 2 divided by the square root of 1 minus r squared, where r is Pearson's correlation coefficient and n here is the sample size. Here n is the sample size. The third step is to determine the critical value. So here in the significance level alpha equals 0.05 and the degree of freedom equals n minus 2, which is 6 minus 2 and 4 here. So the test statistic t, we can't find the test statistics t by using this table. Here the degree of freedom is 4 and the significance level here is 0.05. so here we can find that the t table of this table is equal to 2.776. Let's now calculate our t. Here t is the absolute value of 0.991 times square root of 6 minus 2 divided by the square root of 1 minus 0.991 squared. So we find here the t, calculated t, is equal to 1481. So let's move now to the last step, which is make a decision. We have here our calculated t is 1481 and the t of table, the test statistic t, is equal to 2.776. So here if t is greater than the critical value, so here we reject h0. So here if t is greater than t or critical, the critical value here, so here we reject h0. It means, or it implies, that there is a significant relationship, there is significant linear relationship, significant linear relationship shape between the two variables. If t here is less than or equals to critical value, so here we can say we fail to reject H0. So there is no significance here. There is no significance. In our case, t calculated t is greater than the critical value t of table. So here we can reject H0. So here we reject H0, and we can say that R is different of 0, differs from 0. So here we can make our decision, and we say that X and Y have linear relationship. So statistically significantly linear relationship between the two variables. Now you know how Pearson's correlation coefficient works and why it is crucial in statistics and research. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more insightful content. See you in the next video. Bye.